What's up, everybody? Welcome to System Crafters. I'm David Wilson, and today we're back with another System Crafters Live, where we just kind of hang out as a community and chat about things that are interesting, and maybe talk a little bit about Emacs today, and maybe some other cool stuff. Let's see. Michael David Wilson says that the music scared the crap out of him. I hope that I hope it wasn't because it was too loud. Maybe it was. Hey, Michael. Hey, Thomas. Defragged. Tomas. Nice to see you all today. Hopefully we're going to have a fun time talking about Lispy related topics today. Give people a few more moments to catch up. So this week I've been dealing with another nice little surprise, which is that my daughter's daycare got closed because there was a bit of a COVID outbreak. Luckily my family wasn't affected by it, but they did close the daycare for 2 weeks. So me and my wife have been trying to switch shifts to get some work done here and there. It's been a little bit stressful, but it's fine. I mean, this is what you got to deal with sometimes when you have a kid and you're also living in the middle of a pandemic. So we deal with things as we can. Hello, Garjola, Marcel, Hendrik, Chris, Sanad, TRDV, Vibov, sorry for that. Valentino, Toke, Emmanuel, Felipe, how's it going? Yes, crazy times indeed. Hopefully we're getting towards the end of all of this now, but that remains to be seen. I don't know, people are getting vaccinated, which is good, but you know, we're still in the middle of some new variations and whatnot of COVID, so we'll see how it goes over time. Hey, Marco, Anders, Vlad. All right, so I'll go ahead and just jump right in. So I'm going to talk about some Emacs news that came across my attention this week, I suppose. I will actually give credit to Satya Chua because obviously, you know, the best place to find out about all the Emacs news every week is by checking out Satya Chua's blog. But the few that I picked up this week that are the most interesting are these three. Maybe we'll talk about more if anybody else knows of anything cool that happened. First of all, the biggest news by far, which I tweeted about, I think maybe last week if you saw it, is that the Emacs native comp branch is actually about to be merged into Emacs 28 this weekend. So apparently the work on that has progressed to the point where Eli, one of the core maintainers of Emacs, is feeling pretty comfortable about merging this into master, which basically means that this is definitely going into the next major release of Emacs 28. See if I can zoom this in a little bit. Come on, let's go. There we are. So basically, they're on track to, or he says they're quite ready to land this important feature. The branch was tested on several systems and is in good shape. There's a lot of replies to this thread as well. Some people with minor issues here and there, but most people I think are very excited about this change. Basically, if no significant issues pop up within a week, I will ask Andrea to merge the branch into master on the next weekend, which is around the 17th of April, which is this weekend. So hopefully we'll see that happen. And what that basically means is that with the next major release of Emacs 28, which we don't really know when it's going to happen, but you can assume it will happen probably later this year, that we will all get this new native compilation of Emacs Lisp code by default in Emacs, meaning that all of our Emacs experience is going to be a lot faster than it was before. It's kind of hard to measure the increase in speed. I mean, Andrea's done a lot of benchmarking to show how much faster it is using this natively compiled Emacs Lisp code, but you really kind of have to use it for yourself. The people who I've seen try it definitely have noticed a noticeable increase in speed in doing certain things. It's not like things are like 100% faster, but it's noticeable. You can see that when you're switching buffers, or maybe you're doing certain operations that would take more time in the past. The time is cut down on those things now. So Emacs as a whole feels a lot snappier, and I think that everybody's going to benefit from this change being merged into Emacs 28 whenever that finally does get released. So no more necessity for us to compile our own build of Emacs native comp branch anymore. We'll just have it by default in whatever that may not be true that it's turned on by default. They say they're merging it, so it may be behind a compiler flag, but I would imagine that a lot of distro maintainers would probably turn on that compiler flag because it provides so much value to people. I think the only thing that it might require, though, is a newer version of libgcc JIT. So any distribution that wants to take Emacs 28 with native compilation turned on would have to have the newer libgcc JIT to get whatever the benefits are of that version compared to the previous version. But I think that's a pretty reasonable thing to assume that a distro maintainer would do if they wanted to turn on this functionality in Emacs. Anders says, great for performance, as long as the old ways also work. Yeah, I mean, everything else seems to work just fine. If a package can't be natively compiled, then it will just load it the normal way and just do bytecode compilation, as far as I can tell. So I think it's been fine. Vibov says, future show requests, can you do a show on Emacs for portfolio management? Well, I haven't thought about portfolio management because I don't really deal with stocks and crypto so much. However, I have thought about doing it for finance in general, or personal finances, because there is this there's a collection of very useful and interesting tools for plain text accounting. Ledger being one, Ledger, I think Bean Count is another one. And a lot of those work very well with Emacs because you're writing basically all of your transactions and even your purchase or sell of stocks or cryptocurrency as a text file, and it can do all the accounting for you. Yeah, ledger mode, as Felipe says. So this is kind of an interesting area of Emacs, and I think I saw there was a post about it on Reddit this week where someone was saying that you could do ledger mode in org mode, which I've tried to do in the past. And there's also a video that I saw come up. I think my wife actually pointed out to me a video about using ledger mode in Emacs for managing your finances. So if you want to look into managing your financial state, whatever, with Emacs, then one of these text-based accounting programs is a great way to do that. They're pretty awesome. I've used them a bit for business accounting, so it's pretty cool. All right, so the next thing is this new mode called iComplete Vertical Mode is going to be merged into Emacs 28, or it has been merged into Emacs 28. So this is a new feature in Emacs 28, and I'm going to just show the link that I have here, but I'll tell you more about what this actually is. So basically, well, they added it as a news entry. It must have already been added before. Oh, this is just the news file. I think there's other files in this commit, but iComplete Vertical is a package that was developed. Let me see if I can find the name of the person who did it, because I don't remember at the moment. Antolin, you've probably seen them on Reddit. They comment a lot on Reddit, on the Emacs subreddit. But basically, the iComplete Vertical package is a package that takes the built-in iComplete completion system, which isn't used by default, I think. Maybe it is. I'm not sure about that, but it is a built-in completion system in Emacs. So like if you've used Helm or Ivy before, iComplete is similar in that it provides a better interface for completions, but it has a horizontal layout. So it's more of a typical completion in the echo area. This iComplete Vertical package makes iComplete look more like Helm or Ivy or Selectrum in that you get this nice vertical completion list. And it doesn't really do much more than that. It basically just changes the way that the completions are displayed. All the other functionality that comes from iComplete is stuff that's built into Emacs, and it does a lot of the things like fuzzy matching and a lot of other stuff like that that you get from Helm or Ivy or Selectrum. But now you get this new way to display it. So if this is now built into Emacs, then it sort of begs the question, do you really even need Ivy or Selectrum anymore? There is benefits from Ivy and Helm because they do have a lot of extra functionality and commands built in, Selectron doesn't. Selectron is just an alternate interface for completion, sort of like this. So you don't necessarily need Selectron in that case anymore. You could use the other sort of set of packages that replace functionality from Helm and Ivy, like Consult and Embark and whatnot, with iComplete Vertical. I actually did use this for probably 2 weeks or so, and I liked it quite a lot, but I had some issues with Llvm, so hopefully those things get ironed out in the future. But I think it's kind of a cool way to use things that are more built into Emacs and get some of those same benefits or interface benefits that you would get from Ivy or Selectron. So this is kind of a cool thing to see get merged into Emacs itself, because now we can all benefit from that without having to install an external package. I'm pretty sure this is the same one. Okay, so this is by Omar, and the person who merged iComplete Vertical seemed to be someone else. So I don't know if this is exactly the same. Why is this hanging? Okay, there we go. Let me go back. So, oh, okay, that's a fork. Yeah, it's a fork. Just trying to figure out, like, who was the author of this, because I don't think either of these people were the author of the one that we were just looking at. So let me check the commit. Why are you being so slow? Oh, it's the same thing. Whatever. Okay. Anyway, point being that it would be cool to have this built in. Garshola says, did I talk about Ledger plus Emacs with my wife? Is this due to childcare being closed? No, this is because she like clicks on some of my Emacs videos sometimes, and now she's getting recommended Emacs videos, and she pointed it out to me because she knows that I've been using Ledger for some things, because she's horrified at the fact that I'm using Emacs for accounting. But, you know, that's how you get into these kind of conversations with your spouse. Valentine says, so what about this new Lisp? We're going to talk about that in a second. I just wanted to go through the Emacs news first so that we have plenty of time to talk about the other interesting topic. All right, so the next thing is Org Analyzer. This is kind of an interesting project because it allows you to visualize your clocking information from org mode. So if you use clocking of tasks a lot, this can give you a very nice, I'm not sure exactly what type of graph this is considered to be, but it's reminiscent of the contribution graph on GitHub, where basically you can see how much you are clocking or how much time you clocked on a given day to see which days you've been more productive, quote unquote, or that you clocked more time basically. And also gives you some statistics about these various different things, which tasks you spent the most time on, etc. Some other charts here basically saying what times of day you were most active. So there's a YouTube video here that you can watch that gives an overview of it. I haven't actually tried this out yet, but it seems pretty cool if you just want another way to look at your data from your org mode files and maybe get some insights into how you're spending your time. This is a Clojure app, and I think it's like a local server that you run that you look at this with a web interface. But that's not really a problem. It's just something you have to keep in mind if you want to try to use it. But it doesn't seem to have been updated for a while, maybe 2 years ago, but I would imagine it still works just the same because the clocking format in org mode probably hasn't changed for, 5-10 years. I don't know. So I think you're probably safe to give this a shot if you wanted to see this kind of chart based on your clocking information. Heat map, maybe it's a heat map. So let's see. Let me just scan through the Emacs news list by Satya one more time and see if there's anything else interesting that we could catch. I did see one thing where the maintainer for Centaur tabs is looking for a new maintainer. Basically, I think they don't have time anymore to maintain it. So if you use Centaur tabs, which is basically, I don't know if it's another way to do something like tab bar mode or if it's more like file level tabs. But if you use that, you might be interested in looking into seeing whether you can help out there. And yeah, some other interesting sort of articles and whatnot, but nothing that really stands out to me as much, I think. All right. I think I have some old windows open here, apparently. Okay, so next topic. So I had a very provocative title that I'm creating a new Lisp, and that's true. We're going to talk about why I want to do this. Okay, so over the last year, probably since the beginning of last year, around the time when the pandemic started, I've been hacking occasionally on a few different projects in my free time. One of them that I really enjoyed working on last year was a game engine and a couple of games written in Scheme. Never really finished the games because I got sidetracked onto other things, but it was really fun writing game code in Scheme and actually getting it to compile to binaries that I could distribute on a service like itch.io. To have a game written in Scheme that actually is just a normal executable that someone could run on their computer without having a Lisp interpreter, Scheme interpreter, or whatever on their machine. So I wrote my engine that used SDL2 as a library for doing all the graphics or rendering and whatnot, and wrote some other custom code for producing binaries. I used the Gambit Scheme implementation for that, which is a nice implementation of Scheme that compiles to C. Very cool project. And had a lot of fun with that. But then I kind of started thinking more about, I started learning about data-oriented programming and the entity component system model for doing game engines. And the idea there is that you try to add a greater level of flexibility in the code that you write for a game engine, but also do it in a way that is very cache efficient. So if you know anything about how computers work, whenever you are, when your code is running and you're trying to access things in RAM, in memory, what the processor will do, it will take some part of that memory that you're trying to access and it will load it into the CPU cache. And there's like multiple levels of cache in the CPU. And if you want to have your code be even more efficient, what you should do is try to optimize the layout of your memory for your objects and whatever, so that more of it can be pulled into the cache at the same time, so that whenever you're running an algorithm in your code, like a loop, the things that you need to access are contiguous. They're right next to each other so that the memory that was already loaded into cache can be used before having to load another chunk of memory into the cache. So it's very hard to do this in a garbage collected language like Scheme or Lisp, because in those languages, you're allocating objects on what is called the heap, which is basically just a big block of memory where anytime you create a new object, you're just grabbing some piece of memory from this heap, and you don't really have control over where in the heap your objects are being allocated. So you don't really get this nice benefit of having cache locality, or I guess memory locality, so that it's more friendly to the cache. So I was thinking a lot about that and trying to see how I can make that work with Scheme, because I really prefer using Scheme for writing programs and writing game code. But it's not really easy because you kind of have to hack an existing implementation to make that possible, or you have to do foreign function interfaces to talk to some C code that you've written that do a lot of that memory management, and then surface those things into Scheme using some kind of API binding. So it's not really smooth, and I started thinking about like how I would solve that problem. I also started doing a little bit of hacking on writing audio synthesizer in C, because I want to also write my own tools for creating music and sound effects. So I was looking into that, and it really just seemed like, it wouldn't be fast enough to write that kind of code in Scheme. I mean, I could write it in C, but C, even though C is pretty cool, it's not the most friendly language to use for writing larger programs. You can definitely do it, but it doesn't really provide you with many affordances that you would get in a higher level language like Scheme. So the thing that left me unsatisfied in these projects is I couldn't actually have the power of Scheme with that same low-level memory management and system access that you get with C. So I started to think a lot about how I would approach trying to create a language that would allow you to do systems level programming with Scheme and have all that same access to low-level memory, while still having some of the benefits of Scheme, where you would have, garbage collection when you wanted it to, and to turn it off when you don't want it. Scheme is designed to be garbage collected. I mean, the idea is that you're basically allocating lists all over the place all the time, and they sort of take that problem away from you, like having to deal with the memory yourself. So it will take care of managing memory. It will garbage collect at any given point. But if you know anything about garbage collectors, there's always this problem of, at some point, the garbage collector is going to have to pause the operation of the application and then get rid of all the unused memory, because over time it's watching which piece of memory are being used, and those that aren't being used by some certain point will get cleaned up. So if you're writing a game or any other high performance application, at some point, the GC is going to stop your application, clean the memory up, and then continue forward, which it may only be a few milliseconds, but if a few milliseconds will hurt the performance of your application, then it's something you don't want. So I started thinking a lot, like I said, about how I could write my own scheme-inspired language for systems programming, to take all these things that I wanted to accomplish and put it together all at once. Let's see, what are people saying right now? Some conversation about OCaml. Vibov says, do a series of SICP videos of my new Lisp, maybe later, yeah. OCaml is fast, but the ML syntax isn't Lisp-like. That's true. ML is very cool. OCaml is cool. Bruce Wayne says, do you have any resources, book recommendations for data-oriented programming? I've been struggling finding good resources. There is a book that you can find on Amazon called Data-Oriented Programming. It's pretty good, but I got about halfway through it. I didn't find that I knew exactly what to do after reading it. It's kind of a thing where you kind of have to take the principles of what they're talking about and figure out the right way to do it for your application, because it's not like a one-size-fits-all approach. You have to specifically design your data structures to work with the cache in a certain way to get this performance benefit. So it is kind of hard to do that. Let's see. Wrote the STL. He was very much inspired by Scheme. That's interesting. Okay, so the goals for the project. I have quite a few goals for this project. So I want to write my own Lisp dialect for writing extensible, high-performance applications like video games, multimedia editing tools, text editors, etc. I know I'm saying text editors there, kind of throwing it out there. It would be cool to do an alternate text editor that is sort of inspired by Emacs, but that's like way far down the line. I'm happy using Emacs at the moment, so I'm not really trying to do that. What I would like to do is get back into game programming and also write my own tools for making music and also editing video potentially. So a lot of that stuff would be much easier if I had low-level access to memory and APIs that gave me the niceties of Scheme or Lisp, but I'm still able to do these things. Also, I would like to have a Scheme-inspired focus on tail call optimization and continuations as control constructs. So probably, if you know anything about programming, you've heard about... Oh, my camera is frozen again. Wonderful. Thank you for letting me know. Let me try to switch this out. I'm going to have a problem for a moment, but the audio will be right back in a second. Can you hear me? Garjola says, who would be crazy enough to write a text editor in Lisp? Yeah, I know what you mean, right? Sorry, folks. Give me 1 second. Is it still frozen? Okay. There we go. I think it's fixed now. Sorry about that. I don't know what's going on with the camera. Sometimes it freezes. I think it's either the capture device I'm using or maybe the driver in Linux. But anyway, back to what I was saying. So if you know anything about programming, or if you study programming for a while and study different programming languages, there's this concept of tail call optimization or tail recursion. And basically that is an optimization that enables you to write functions that call themselves, that the function that calls itself is a recursive function. And if you write your function in a certain way where the last expression of that function is a call to itself, then the compiler can turn that into a loop instead of a separate function call. So this allows you to use recursive functions as a looping construct, as a more generic looping construct, and you can save yourself a lot of stack usage, and you won't have this whole Stack Overflow situation if you have tail call optimization. So Scheme is very focused on using recursion as a looping construct. In fact, I don't think there's any built-in loop construct in Scheme aside from just recursion, which I think is kind of interesting. And once I actually wrote code like that for a while, I kind of liked it a lot because you have one way of doing things and it gives you the power to do basically anything that you wanted to do. And if you wanted to, you could write a macro for like a while loop or something if you wanted, but it's not really necessary to do that. There's also continuations, which is maybe even a more generalization of that same idea, where a continuation is when you have a function that calls another function, and then so let's say function A calls function B. So when function B returns, it's going to give some value back to function A, and then the A will continue executing. In a continuation-based design, A will call B, and then it will pass another function to B, which is the remaining code of A to be executed once B is finished. And there's no return value being passed back. So basically all your code is just jumping from function to function. And when you have your code set up like this, it gives you the ability to do more interesting control constructs where you can implement things like exception handling or green threads or channels or a lot of other things like that are not very easy to do in a normal programming language where you have functions that return values back to the previous function. So Scheme is very heavily based on this idea of continuations, or at least some of the implementations I've seen are based on compiling to continuations. So this is something I want to try to do as well, because I think it could make the code a lot more flexible, I think. Ishan asked how to learn Emacs Lisp. Check out my Learning Emacs Lisp series on this channel. We've got about 7 videos now where you can check that out. Yele says, the Spring Lisp Game Jam 2021 just started. If you're extremely fast, you can still participate. Yeah, I would love to do that, but that's not going to happen. Anders says, continuation saves the context so it can continue. Yes, that's absolutely true. All right, so while the language would be Scheme inspired, it will not follow the R6, RS, R7, RS specifications. I like what Scheme is trying to do there. It makes a more open design where you have a base language specification, and in the case of R7 RS, or even R6 RS, there's a very small language spec, and then there's a larger language spec for a more complete language, and then there's this whole what is it called? There's a specification convention, I suppose you could say, where it's called SRFIs, SRFI. So you can write your own specification for a SRFI, basically a new language feature that other Scheme implementations can implement, and then any implementation can pick up that specification and implement it. And the idea is that code should be compatible across Scheme implementations so long as they follow these SRFIs and the base language spec. In my case, I would prefer to have a more opinionated language that has a very specific way things are done and isn't really extensible by default like the way that Scheme is. Scheme is sort of intended for an academic setting, or at least it was created in an academic setting, and you see a lot of researchers using it because it's based on lambda calculus. People use it for a lot of computation research. But what I'm doing is a lot more practical, and I want to focus on making this a good language for systems programming. So I'm not going to follow the spec. I'm going to take inspiration from a lot of things I like about Scheme, but I'm not going to make it an actual Scheme language. So this is a Scheme-inspired language, basically. So also, I want to try to do a mixture of dynamic and manual memory management. Like I said before, garbage collection can be a problem for performance in programs, because if you have your program pausing every now and then to clean up any memory that's being used or not used anymore, then if you have a high performance code like a video game that needs to have a constant frame rate, or maybe a synthesizer that needs to keep up with the buffer, you need to avoid this kind of thing. So what would be nice is if you could use GC in parts of the code where it makes sense to use it, and then in other parts do manual memory management. I don't exactly know how this is going to work yet. This is something I need to experiment with, and I don't even really know if it's possible, but I'm going to try it and see what happens. That's sort of the point of this project, is to experiment and see if I can accomplish some of these goals to make a language that works for my use cases. So we'll see whether it works or not. Maybe you'll hear about it later if I actually make this successful thing. I know it's possible to do a Lisp with manual memory management because I know that the Carp project has done that to some degree, so that's kind of a cool thing. A couple people have mentioned other things. Miljan says, have you considered Clasp? I haven't looked at that. It sounds familiar, but I haven't looked at it at all, I think. Anders says, is the LWT or async in OCaml what you're looking for? You mean like for continuations? I know that OCaml does have a continuation-based design, or at least some of the implementations do have a continuation-based design. So they're similar to Scheme in that sense. So also it'd be cool if certain sections of code could use its own memory management paradigm. So I don't know if you've heard about the Zig programming language that's currently being developed by Andrew Kelly, but it has a very interesting concept of being able to pass in a particular allocator pattern for a function that's being used. So you call a function, and any function that wants to allocate memory on the heap has to accept an allocator as a parameter, and it will ask that allocator for a certain amount of memory, and it's that allocator's job to decide how to allocate it. So you could have various different implementations of allocators that are for different purposes, and then if you pass it into a function like in the Zig standard library, it can allocate that. It will allocate the memory based on how you want it to be allocated. I think that a very similar thing could be done in Scheme, where you could have a special form like, with memory allocator, pass in an allocator, and then the code inside of that will have that context for whichever memory allocator to be used. So I think that you'd be able to accomplish a very similar thing and not actually have to pass the allocator through, because it would be part of the context of the functions being executed. So that's something I want to experiment with. I think it might be kind of cool. It also could be a total failure, so it'll be interesting to see what happens. Another thing could be deferring garbage collection in a code section until later. So basically you say, run this code, don't run the garbage collector at all until it's finished, something like that. I think that could probably be done in other languages, but it could be another way to keep the GC from running when you don't want it to. Ed Bowler says, is that memory allocation customization a usage time thing or a definition time thing? I'm not sure yet. I would probably go for usage time, but I don't know what kind of problems I might run into with that. So it's really why I have to experiment and try it out. These are all my goals right now, so I don't really know if many of these things are going to work. I'm just I'm setting the course for myself, basically. JIT compilation of code instead of writing an interpreter if possible. So it's very common that a Lisp implementation will have an interpreter as a thing that you're using whenever you're in the REPL or you're doing dynamic code evaluation with the eval function. I want to see if I can avoid using an interpreter and just go completely to both static and dynamic native code generation compilation at runtime. So either you run a compiler on your code to produce a binary that has your code in it, or you can go into a REPL or run a script basically in the interpreter, let's say, and have it JIT the code to native and then run it. So JIT means just-in-time compilation. So instead of taking Lisp code and then sort of reading it and evaluating it step by step, you take the Lisp code and you compile it to native code in that process and then run that code as a function. I think it's possible because there's a lot of languages that do JIT. Even Emacs Lisp will JIT to bytecode or to native code with a new functionality, the new native comp branch. So long as I have a compiler toolchain that can produce machine code based on the code that's read in, then I should be able to do JIT just fine. Garjola asks, why are you not using GCC or LLVM? I'm going to talk about that. Oh, actually right here. Yeah, thank you. I skipped that section. I forgot. So yeah, that's the idea. Basically, I just want to do JIT compilation for anything dynamic and do static compilation for anything where you're building the application up front. Anders says having or not REPL doesn't need to have anything to do with JIT. Yeah, of course. Felipe says, whatever you do, make sure to consider at least AR64 as a target. Where else is that used? I know that Termux on Android uses it as a target, which is interesting, but I don't know where else that's used. Right now, I'm only looking at 64-bit Linux, but I am interested in other architectures as well. I'll talk about that too. So the thing that I missed here is that I want to have a fully custom compiler toolchain that is tailored to compiling Lisp applications. Have all of the compiler, the assembler, and the linker. No GCC or LLVM. The reason why is I'll talk a little bit about it more later. But the idea is that if I want to have a very special implementation of Scheme or Lisp, I need to be able to have total control about how these things get represented in machine code and also how memory gets managed, etc. If I were to use GCC or LLVM, I'm basically playing in their space using what they have as a model. So GCC, I could basically write out my code to assembly that GCC's assembler can read, and then I could use the rest of the GCC toolchain from that point forward. But then I'd be beholden to whatever GCC is capable of, which maybe is capable of a lot. But, I would have to learn all of the GCC internals enough to be able to do this correctly. Same thing for LLVM. I would be beholden to their tool set. I want to actually have my own tool chain that's completely standalone that doesn't need GCC or LLVM or any other existing tool chain. I want to be able to produce binaries myself using my own code. AR64 is ARM64. Okay, yeah, definitely I'm going to target ARM. I need to have that working for sure, but not at first, but eventually I will. All right, so here's another part of the important parts, I guess. Now, produce small standalone binaries by tree shaking dependencies. So for a simple application, it'd be really good if the binary was 5 megabytes or less. If the code is only a hello world, it should be definitely less than 100K. I mean, this is sort of more a aesthetic thing, I guess. I think it's kind of ridiculous to see a simple program to be like 50 megabytes, which you see a lot these days with, anything that's based on Electron or Node, I guess. If you compile a Node application, quote unquote, compile it, if you make an exe out of it using something like NEXE or Electron or whatever, you're carrying along all of Chromium with it. I think it's kind of ridiculous to do that. So I would prefer it if I could produce a binary that has nothing but the absolute necessities for that program. So for a larger program that has more dependencies, you're going to have more code, but we should only pull in the stuff that's actually being used. So this is the idea of tree shaking. If you call a function from a library, you should only have in your output binary that function plus any other functions it requires, and not everything else that comes with that library that you're pulling in. Obviously, that will only work for code written in this language, because I can't do the same thing with static binaries unless things are broken into separate segments. However, I think it's possible to do the tree shaking with my own language and tool chain. Basically, I could do tree shaking at the compiler level, and I could potentially do it at the linker level too. Because when I'm linking in code, I could just get rid of things that aren't necessary. So smaller binaries are cool, and also it would be cool if I could make it easy to include other information along with the binary. So let's say I'm trying to ship a game to somebody. If I could ship a game that has all of the media files baked into the executable, I could just give them an exe and not have to give them all like a folder full of media files as well. So there's a lot of things that could be done there that's pretty interesting, especially when you think about how ELF binaries and whatnot actually work, where you're creating the memory of the application in the binary, and then it just gets sort of mapped into RAM whenever you run the application. It could be pretty, if you have a small game that doesn't have a lot of assets, then it can make a lot of sense to have everything just baked into that exe. Then it's really fast because all of your assets are already loaded into RAM at the time that you're running the code. You don't have to load things into RAM or do any of that management. So that's kind of an interesting idea, but it's just something that's sort of a fun idea to me. So the standalone binary can contain the compiler for live code patching, but it must be minimal enough to not bloat the output. So one thing that people commonly do with Lisp-based languages is you compile your application, maybe you deploy it to a server, or maybe it's just running on your computer, and you want to connect to the REPL that is in that application to maybe diagnose a problem with it, or potentially patch the code while it's running. This is one of the benefits you get with a Lisp language, is that you can do live patching of code. So it should be possible to do that, and if you wanted to do that, you would need to at least include enough of the compiler, or however code is being evaluated into the program so that you can do dynamic code evaluation while the program is running. But whatever that machinery is, it shouldn't be so big that it just makes the output executable a lot larger. So the minimal set of things needed for that should be what you get, and not like the whole standard library, etc. Another thing is it's got to interoperate well with C libraries. It's not very hard to do that because the C calling convention is pretty easy to deal with in assembly. So it's really just a matter of being able to link. The linker implementation needs to be able to link to C libraries easily, but I think that's not super hard. It's a lot harder if you try to link to C++ or something else, because you got to deal with name mangling and all kinds of other stuff. But at least with C, it's pretty easy. So that's not going to be a hard goal to reach. And also, if this is a Lisp, we got to have rich macro facilities. It's not something I'll do at first, because really you just need to get the language off the ground before you start thinking about macros. But it is something to think about later. One thing I don't like about the traditional Lisp style macros like def macro, etc., is that it's basically templating code, which is fine. There's no problem with it. It's very flexible. You can do a lot with it, but you sort of lose the ability to do good syntax errors whenever someone is using a macro. So I want to look into using the more scheme style defined syntax, etc., or syntax case to do macros, so that maybe you have a more structured way to define a macro, and you might be able to provide better developer tooling on that. I haven't really used schemes defined syntax very much, but I get the impression that it's intended for making it easier to trace where the output code is coming from. Another thing would be Go-style dependencies, which is sort of becoming more common these days. However, I think they're also changing their mind on this, so we'll see how that goes in practice. But the idea being you would pull your dependencies from Git repositories, and not from some package repo where they've put together a package for a particular version. And then you would lock to specific commits or tags for your dependencies for the project. So it should make your builds more reproducible if you can just pull everything back down to a particular set of commits for all of your dependencies. And also, a lot of the core stuff of the language would be as separate dependencies and not part of the core distributable of the language. So that would allow you to pull in whatever you needed and still, do this whole tree shaking thing where you don't pull in a dependency if it's ever used, and then you can choose which ones you want, basically. Ed Bowler says, where do you stand on reader macros? I think they're kind of necessary. I've never implemented them before, so I don't really know what it takes to do that, but it just seems like another way to express macros. Where do you stand on reader macros? I'm interested. Ramsey says pattern matching. Yeah, I think it'd be cool to have a way to do pattern matching. Ramsey's also asked, what would be the name of the language? I'll talk about that a little bit later. So compilation backends, I would definitely want to target, not only Intel, that's pretty obvious, but also ARM and WebAssembly. So ARM for mobile devices and WebAssembly for compiling something that can be run in a browser. It's nice to be able to deliver a game to someone or even an application to someone via the browser, because it's a lot easier than having them install a program on their computer. So that's a good target. And it's also kind of interesting because the higher level representation of WebAssembly is written in S expressions, so it's kind of cool to be able to write something that translates to another form of S expression, which is basically Lisp style expressions. And lastly, it would be nice if I could allow the user to write assembly for some performance sensitive functions like in C. So if you didn't know this already, in C, you can actually drop down to assembly in certain sections of your code. You can write assembly directly in the C code and have that be compiled out whenever you build your program. I think it would be cool if you could do the same thing with this language for performance-sensitive sections that you want to have very specific control over which instructions are being used, and also how memory is being accessed, etc. However, this will make that code be very platform-specific because you are writing assembly for a specific platform. If ARM assembly and Intel assembly are different, WebAssembly is different. So as soon as you do this, you basically have to write assembly for multiple platforms, unless you're only targeting a single platform with your output. Toke says language name system. This way it will be completely impossible to search for. Yeah, I'm definitely not going to do that. It's a cool name, but it wouldn't work too well. All right, so that's all the goals for the project. So let's talk about what things I need to write to make this possible if I'm going to do it all myself. So obviously I need a compiler. To produce standalone binaries, I'm going to need a compiler that can take the code of the language and produce an intermediate representation that can be optimized and ultimately turned into a form of assembly. So this is basically what any compiler is doing, is taking the source language, it's parsing the syntax, it's analyzing the syntax, and then it turns that into some kind of intermediate representation. Typically, it would be assembly language. For other languages that run on top of a VM, like Llvm, it would be the intermediate language for that runtime. .NET also has a similar thing where you compile your code to something called IL, which is the intermediate language. And it all sort of looks like assembly, but it gets interpreted differently. The idea with some of these intermediate languages, or I guess basically all of them, is that at some level, the intermediate language could be translated to multiple platforms. If you have assembly language assembly language can be written for a specific platform. I think that there's not really a common way for it to be done for multiple platforms. However, the intermediate language for Llvm, at least I know for sure, is done in a more abstract way so that it can generate code for multiple architectures, so x86 or ARM, etc. I think I'll have to do a similar thing, and what I would do is probably create an intermediate representation that is more focused on the paradigms of Lisp and Scheme, and then have that go to another lower level of representation that's more like assembly, basically. So the compiler would need to have parsing of the language and also macro applications. So if you think about it, in Lisp, you're sort of programming the compiler in a sense, because when you write code, that code gets translated into whatever the lower level representation is that gets used, whether it's bytecode or whatever. But when you write a macro, that's like a higher level construct that then gets turned into output code. So the compiler itself can be programmable, and we could take that concept even further. I don't really have good examples of that right now, but one thing that is kind of interesting, like in the language Zig, is that they have this concept of comp time, where you have certain code that gets evaluated at compile time to do code generation in some cases, or maybe picking types for some part of code. You can definitely do that already in Lisp languages, but I would like to think a little bit more about how to make that experience even better so that you can do code generation very easily in this language, aside from just the typical macro syntax. The compiler will also need to do conversion of code into continuations. So like we talked about before, a continuation is a model where when a function is executed, the last parameter to that function is the function to call with the result of the function that's currently running. And that allows you to sort of chain together a lot of operations and then decide how these things pass along, I suppose. So you don't have a stack anymore as you used to. It's a different kind of, you're basically jumping between different functions rather than having a stack like you would have in the past. So this requires looking at the code and looking at the way functions are being called and then converting that code into continuation. So part of the intermediate representation of the language would be this conversion into continuations instead. Then you need to have a module system that works for the compiler, so you can pull in different modules of code. This needs to be something that's added at the beginning, because one thing that Scheme implementations found is that whenever, I think it was R7RS came along and they finally got this library concept, it kind of had to be bolted on to existing Scheme implementations. And they all sort of had their own to begin with. So it'd be good to have a solid module system from the beginning. Anders says dynamic compiling might be a problem for minimizing the binary size. Yeah, definitely. I mean, I have to find a way to balance that. And also, it has to be opt-in, I think. And then tree shaking is a thing here where whenever you're compiling the intermediate output, you don't include anything that's not actually being used. But that's pretty, well, in many cases, that's easy to figure out just by looking at the code, because the code is going to be clear about which functions it's calling. The only place where this isn't clear is if you're using eval in your code, because eval could be calling anything. So you kind of need to disallow eval to some degree, or if eval is ever used, then tree shaking gets turned off. I don't know how to deal with that yet, but that's something that will have to be considered in the future. And also, the compiler deals with optimization as it's doing the intermediate output. I mean, you do things like dead code elimination. For instance, if the compiler can determine that some code path, like an else statement of an if statement, if it can tell that that's never going to get run, it would just throw it away. It won't ever try to run it. So the intermediate representation will have only the necessary code prepared in a format that is ready to be converted into machine language. So we're basically getting it ready to be converted over to machine language. The other job of the compiler will be to manage that just-in-time compilation at runtime. So we need to be able to dynamically evaluate code. So the compiler is going to have to work in a JIT setting as well. So not just static compilation, but JIT compilation too. Andre says you might define a subset of functions for eval so you know when you compile. Yeah, something like that would have to be the case, I think. All right, so the next thing that's necessary is an assembler. So an assembler takes a low-level representation of your code and turns it into machine instructions for the target platform. So if you've ever looked at assembler code, you've probably seen it before. It looks something like this. Different assemblers have different syntaxes. So an assembler is actually it's actually its own language. So the GNU assembler has its own syntax. I think this is the GNU assembler syntax. NASM, NASM has its own syntax. MASM has its own syntax. They all have their own syntaxes. They're relatively similar. However, they're all their own syntax basically. So an assembler will basically parse that syntax and then turn it into machine code. Now, the interesting thing here is that it looks like this should just be an instruction to the machine, right? Like it's move, you're moving a number into a particular register, moving the digit 1 into the EAX register. However, this actually gets turned into a number of different operation codes for the target processor. And it's not just this one move instruction. There's actually multiple instructions that deal with different sizes of numbers or different registers or memory locations. So the job of the assembler is to actually know how to translate this one line into the right operation code and the right parameters for what the user intends here. So writing assembler does have some work involved because you have to know what the operation codes are for your target machine. And you have to know how to translate the code that is written in your assembler language to those opcodes. So let's see, did I already cover that? Blah, 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 blah. Yep. So the assembler needs to know the appropriate instruction encoding for the target architecture. In my case, for right now, it's 64-bit Intel, so that it can produce a proper opcodes and use the processor effectively. One other interesting aspect here. So I'm going to make it so that the assembly representation for this language is written in the language itself, which kind of makes sense. You know, it's all symbols. And the implication here is that you could actually use macros in the assembly code so that you can have code generation at the assembly language level. So whenever you're writing your assembly, even if it's inline instead of a function definition inside of this language, you could call a macro that then expands out to more code. I don't really know how I'd use that yet, but it'd be very cool to have that possibility. I don't really know if there are other assemblers that have a macro-like capability, but since we're doing this in a Lisp, it totally makes sense to try to make that possible. And the output of the assembler will be object files, typically in the system's object file format. These object files will be used by the next component in the toolchain, which is the linker. So when you compile your code into machine code, generally you're wrapping it in a file that is formatted in a way where the system understands it, because the operating system needs to be able to load your executable and any libraries that it uses into memory and to link these things together. Basically, it needs to find the memory addresses of a function that's being called, or the memory address of a function being called in another library, and then link those together basically at runtime. So you need to write your object files out in the format that the operating system understands, basically. So the linker's job is to take the object files produced by the assembler and produce a working executable. So for now, I'm only focused on the ELF format, the executable and linkable format, because that is a format that is used in Linux. I'm using the 64-bit variant of that, basically. And basically, the task that it has is to take the code from the modules that you've compiled to object files. So let's say you have a project where you have multiple modules that you are pulling together to make a whole program. Each of those individual modules might have their own object files compiled out. And then when you want to compile the final application, the executable, your linker will take all those files and combine them together into one file where all of the segments, excuse me, of the output code from all of those are merged together into one output file, and then all the sort of memory addresses are lined up correctly. This is also used for integrating static libraries. So let's say you have a library that you want to statically compile into your program so that you don't have to load it dynamically on the target system. So if you want to have one executable that pulls in, let's say, SDL2 or anything else like muscle C, you could statically link that into your program so that it becomes a part of your executable. So the linker is responsible for doing that as well. Also, finding references to symbols in dynamic libraries. So whenever your code refers to a function that would come from a dynamic library, like a DLL or was it like a .a file, I think, on Linux, you have to look up that symbol in that library to know where you're referring to it, so that later, whenever your application is executed, the loader knows how to find that dynamic library and then find the function that you're referring to. Also, building the memory layout of the initial process. This is actually kind of interesting because it gives you the ability to have more control over how your programs get represented in memory in the end. So the ELF format is very specific about memory locations of different parts of your program. So there's different types of data that you can put in the binary. Some of it's program code, some of it's like string data, some of it is actual memory locations. So like global variables that you define can be defined in parts of your program output. And you are able to define where all these things get located because the format is set up so that you have to tell it the memory address in the file where these things are found. And then whenever your program gets loaded into memory, the operating system basically sets up the memory of the process so that it's pointing to those things in the original executable. So you're setting things up in a very specific layout in the binary so that the OS can just map directly to that and know where those things live and where they map to in the virtual memory address space for your program. So it gives you the ability to have better, if you write your tools yourself, if you write your linker yourself, you'll know exactly where everything lives in memory and you'll have more control over that, which gives you better control over things like, cache locality and various things like that. You can also encode a lot of information that gets kept with your application about like how the program was compiled, information about symbols, memory management, all kinds of stuff like that. So it gives you a lot of control if you are producing your binary yourself. Now, you may not need that. You could just go along with using, GNU's linker or Llvm's linker or whatever, but it's kind of interesting to have the opportunity to control all of that yourself. It is a lot of work, though. Managing memory addresses for everything. So basically the same thing. You're organizing the memory layout how you want it, but the linker has to keep track of the addresses of various functions in the code, various functions you're calling from other modules, a lot of stuff like that. So it is a lot of bookkeeping, which can be a little bit tedious, I think. I haven't gotten to that yet. I started looking into it a little bit, and I'm having to defer to some resources to learn more about how to do it correctly. So the linker is the part of the code that is very OS dependent. So I probably won't get to Windows support for a while and Mac OS support for even longer because they all have their own binary formats that you have to learn to produce. They all have a lot of the same ideas, basically, where you have, segments of program code, segments of read-only data, etc., things like that. But because they're different, you have to follow the specification for the binary format for your particular target system, and it just takes time. So since I only care about Linux 99% of the time, I'm just going to focus on that and learn a lot, and then later I'll focus on doing other operating systems. Andres says, this is a good point, might want to save the libraries in an intermediate format from the compiler, and then the linking will be later steps of the compiler. Then it can optimize the total program, not just the objects. Then the linker can be standard linkers, but the compiler could optimize much more overall. Yes, I have thought about that too. Instead of storing an object format for the module output, store a different intermediate format, which could be even in S expressions, or it could be binary, so that more optimization could be done at the linker. I've been reading some stuff which says that some linkers do some things like this for more advanced functionality. So this is another benefit for being able to write your own linker, which is you have the ability to choose to do these things and maybe optimize the whole tool chain towards your specific use case. When you have a tool chain like Llvm, you have to support so many different use cases that it becomes really complicated. But if you're writing your own tool chain for a very specific language and a specific purpose, then you can be very targeted and not have to have all the extra behavior that maybe you don't really need. All right, so the runtime. Once I have a tool chain that's capable of compiling basic code, I'll also need some kind of lightweight runtime or standard library that can implement memory management and other low-level tasks like module loading. The goal is to make this part as small as possible so that the output of the program isn't weighed down by unneeded code. So the core parts of the language should be very minimal, and then anything else that is sort of convenience facilities should be separate modules that get pulled in as needed. So I don't really know what the right balance is for that. I mean, I'm sure that I can look at the C standard library or things like that to see what the core elements are. I would think that a lot of that is going to be the basic system calls for the OS that are needed for operating the program. Like you need to allocate memory, you need to open files, just the very basic things like that, because you can't really pull in a module unless you can open a file. So the core things like that will be needed. Also, basic memory management would be a part of this runtime, so that you know how to allocate objects, etc. So all of that sort of really, really core stuff would be part of the runtime, and then everything else would be separate modules, which is basically the next component which is needed. So I'm going to try to produce a set of modules that feel like a coherent standard or library for the language, providing all the functionality and data structures you could possibly need for day-to-day coding. The compiler itself may not come with these parts bundled. So the compiler could be just a small executable itself, which takes care of the compilation, assembling, and linking of the code, but doesn't provide any of the other external parts, those things you would need to pull into your code via modules. So this does mean that compiled programs wouldn't be able to arbitrarily load modules that weren't compiled in with it. But I'm going to try to find a way to make that possible, perhaps with a secondary tool. So you could have a tool next to your program that could deal with pulling in modules, and then you could load those dynamically into the program if necessary. Garjola says, you haven't talked about syntax. I hope white space will be sensitive and curly's mandatory. This is a Lisp language, so it's going to have parentheses. And it's going to look like scheme, basically, but the set of functions available will be slightly different, and some of the code constructs will be different. But it will definitely be S expression based, parenthesis based. All right, so the plan. Now I've talked about the goals I have and also components that I need to implement. So let's talk about the plan for this language. So I'm actually starting at the bottom from this project. I want to write my own standalone toolchain that doesn't depend on anything else aside from the language and compiler that's needed to bootstrap the project. So I've started working on the assembler and linker first, which may sound strange, but it has a few benefits. So it enables me to reach my goal of producing my own binaries faster without relying on external tools. Now, I know a few people have been mentioning that I should use external tools, but I feel like that goes against my goals of wanting to be able to produce exactly what's needed. Sure, I could save myself a lot of time by using GNU assembler or GNU linker or Llvm or anything like that, but that's not really the point. The point is to generate optimized code for exactly my use cases. And it makes sense to start from the bottom because it enables me to reach that goal of producing my own binaries faster, because I don't have to work with those other tools. I mean, sure, I could write assembly code right now and run it through GNU assembler and linker and have an executable that's very small. That's fine, but I want to be able to do it myself also. I want to have my own compiler that can do everything end to end without requiring external tools. So this is what I need to be able to get to that goal. It also allows me to learn how these components work so I can think holistically about the entire tool chain when I start writing the compiler. So if I've already been writing the assembler and the linker, I'm already thinking in terms of how the output of the program should be represented. So then when I start writing the compiler, I know what I need to do to translate the language to the lower levels of the tool chain to produce the right kind of output. Garjola says, yes, you could save a lot of time if you didn't invent your language. Yeah, I could, but I want to. So I can also build up everything incrementally and redesign as needed. My choices aren't limited by someone else's tools. So by doing this, I'm able to write only what's needed at any given moment to accomplish the goal that I have at the moment. So right now, I just want to get a very simple binary produced from machine code. And I only have to write what's necessary from the assembler and the linker to do that. And I only have to learn what's necessary to do that. So later, whenever I have to start dealing with dynamic libraries or maybe more complicated assembly constructs, I can learn how to do those things and put those together. But for now, I can be very agile and only implement what's necessary and then get to the point where I can start implementing the language itself and have it be useful for very simple tasks and then just build it up from there. Also gives me the ability to redesign things on the fly if I realize that what I've done so far isn't optimal for the design that I want to go to next. So I feel like it's a better way to try to build all this stuff up. Just try to do things in small increments, validate the design, validate that it's working for whatever my current goal is, and then keep moving forward. And to accomplish this, I'm going to use Chibi Scheme as the bootstrapping language because it's easy to embed in a simple C application. So it means that I can compile an executable with Chibi Scheme statically linked in, and then have that be a standalone binary that can be the compiler for my language. Now, obviously, I can't write the language in the language itself because it doesn't exist yet, so I need to have something else to use. But this is actually really common in the space of writing Lisp implementations. You basically just use another Lisp implementation to write your Lisp. And then eventually, whenever your language becomes sophisticated enough, it can start to compile itself, and then you can just go from there. So, my goal is to use Chibi Scheme to implement what I need to implement in Scheme for now until what I've developed is sufficient enough to compile itself at some point in the future. It probably will take a long time to get there, so it will be Chibi Scheme for now. But, it's fun to do it that way. It would be a lot more fun than writing it in C, I think. All right, so the question you've all been asking yourself the whole time, why? Why am I doing this? Primarily to learn. I think it's going to be a lot of fun. And it's a great opportunity to write a fully Lisp-oriented tool chain from the ground up and optimize everything for the goals that I mentioned before. Garjola says, David is going to spend a lot of time on this project and won't have time to do videos and live streams. That's not the case. I'm going to be doing the same thing. If I was spending all my time on it, I wouldn't be here today doing the live stream or produce a video this week. So don't worry, that's not going to happen. Excuse me. And, this idea is kind of irresistible to me. I started thinking about it about a year ago, and I never really had time to do it in a lot of ways because I've been, full-time job, raising a kid, and also making Emacs videos in my free time. I haven't had enough time to really spend on it. However, it's just irresistible. I can't stop thinking about it. It just keeps coming back to me every now and then that I want to do this. So I'm going to do it and try to see how it goes, basically. And obviously, I don't have a whole lot of free time, so I'm going to try to do it as incrementally as I can, but it'll be fun, I think. Obviously, another option is using something like Llvm, but Llvm is huge and a whole different system I'd have to learn anyway. And in fact, I did look into that last year. When I started thinking about this, I looked at Llvm to see if I could leverage their tool chain, and it's super complicated. It does a lot. It does a lot of really good things, but it's... At that point, if you're learning how to use Llvm, you might as well learn how to write stuff directly to the system because you're going to learn more that's more widely useful to you anyway. Of course, if you learned Llvm, it'd be great if you were to work on some other language that used Llvm, but I kind of feel like Llvm is like a stop in the road for a new language until they decide to go all the way down to the metal themselves. Zig is going through this process right now. They started working on Zig with Llvm, and now they're trying to self-host. They're trying to write Zig directly to output binaries without Llvm. I think the same thing for Rust. I think they're trying to get rid of Llvm too, or they're already in the process of doing it. So usually when someone uses Llvm, it's just to get things started fast, and then eventually they get rid of it. I'm just going to skip that whole process because I would rather learn the low-level stuff because I think it's going to make me a better programmer, and it's also going to be fun, and I can do things the way I want to do them. So there's no reason not to do it, I think. And by writing the toolchain from the ground up, every aspect of it can be optimized for the control flow and memory management schemes of the language, which are continuations and this hybrid GC manual memory model, which, as I've said, I don't know if it's going to work, but we're going to find out. It'd be similarly hard to do this work with existing tool chains, so it's better to just do it myself and learn a whole lot in the process. And at the end, what I want is a tool that's tailored to the kind of projects that I want to write and produces the kind of programs that feel right to me. So, you know, not bloated programs, programs that are optimized to the use case, programs that I understand fully what's going on with them, that I can debug easily, etc. And once it's working, I'm going to write a lot of the programs that I've been dreaming about for years. So, you know, game development, writing my own music authoring tools, video editing tools, etc. I want to do a lot of things like this. And I feel like if I have a language that is fully attuned to the way that I want to do things, maybe it will make things easier. So part of the reason why I'm telling you about this project today is to see if you'd be interested in hearing more about building a compiler toolchain from scratch. Obviously, I'm not an expert. I've learned a lot about this in just a couple weeks, but this is like scratching the surface. It's not even close to knowing what I need to know to do this. So I can share what I'm learning over time, but I can't actually speak with any authority yet. So I wouldn't really make a video series on this for quite a long time. However, I might bring it up in live streams like this to sort of give status updates and talk about how I'm going through this process. Ed says, is it worth thinking about the dev story when designing the compiler so you could easily create an LSP server using some shared components? Yes, 100%. I didn't mention that here, but it's something I'm already thinking about, how you could basically set things up so that it's very easy to provide a language server functionality to get rich language support in an editor from the beginning. It is sort of at odds with REPL-based development, like you would see with Slime or Cider, etc., because usually everything's supposed to go through the REPL. But I think a hybrid approach where you have both language server plus REPL could be pretty interesting. Let's see. So yeah, this project is not going to be meant for other people for a long time. It's really just meant for me to play around and to learn and have fun hacking. However, if you are interested in following along, I set up a mailing list, doesn't have any mails on it yet, that you can find at SourceHut. I'll put these links in the description of the video after it's over with. Also, the currently empty compiler repository is there as well. I haven't checked anything in yet because the code that I have right now is total crap, and I'm not ready for people to see it. So I'm going to check it in a little bit later, probably in a couple weeks. So people who were asking about the name before, the name that I'm going with for now is Mesh, or maybe you could say it is Mesk. And the reason why I went with that is because it's basically Scheme, but with the letters rotated a little bit. So sort of just a cheeky play on the name of Scheme, but it sounds cool, and I think it's cool to go with for now. It isn't the easiest thing to know how to spell whenever you hear someone say mesh, because they're going to think it's M-E-S-H, but since I'm not intending for this to be some kind of, you know, super popular language that everybody wants to use, I don't really care whether people can find it or not. If they know who I am and they know about the content that I create, they'll probably figure it out at some point. Other than that, I don't really care too much. This is not really a project that's meant to be something that will be widely adopted. It's just a fun thing. So I think it will be fun for the purpose of me learning, and I think it will be fun for the purpose of teaching people some things about compilers over the span of years, I suppose, as I'm working on this, so that you might learn some things too. And also, it will give me another language to use for hacking on cool projects that we do on this channel. So I think it's a good thing to do. I'm really excited about it. It gives me a lot of inspiration to learn, and hopefully it will be interesting for you to hear about as well as we go on. So that's the end of that section. We've got quite a lot of time left, and I don't really have anything else planned, so we can definitely just chat. If you have any questions about Emacs or GNU Geeks, or programming, or Lisps, or Scheme, or anything like that, please feel free to ask. And if we don't come up with anything to talk about, then I might start hacking on some kind of code of some sort while we're here. Let's see if I missed anything from before. So Tomas was talking about red. I don't really know about that. And let's see, Ed was talking about Clojure's approach for reader macros. There are some system-defined reader macros, but you can't, as a normal developer, extend the reader except for data translations with tagged literals. Yes. I don't know that I would allow arbitrary syntax, or arbitrary reader syntax to be added to the language, because that would make it harder for syntax analysis for developer tools and for compilation. So I think I would stick with the reader syntax that's built, sorry, the reader macros that are part of the language so that they can be analyzed effectively by the compiler. Having the language be fully malleable to the point where you can do anything with it is just going to harm the ability to compile and optimize effectively, I think. Ed Buller says, common Lisp reader macros are too powerful and make it difficult to read and work with other people's code. I can agree with that. Anders mentioned before that MASM stands for macro assembler, but it doesn't have very powerful macros. So that's interesting. I didn't know that. Anders also said, as long as macro have good type checking, it could be useful, even as common Lisp macros. Yeah, that could be the case, yeah. Let's see, what else? There was a thing that was said here that was really interesting. Anders says, I have seen some assemblers that use different levels of macros, so it should be possible, but assemblers today are much more advanced. Yeah, I think that's definitely the case. Might want to save the libraries in an intermediate format. I did talk about that one. So having Lisp macros in an assembler should be pretty cool, I think. We'll see whether it actually becomes useful for anything. It could be cool for things like loop unrolling, maybe. But as I said before, there's not a standard looping structure in Lisp. However, actually in Scheme. But for performance sake, there could be a case to be made for it to have some kind of loop that is very specific for looping over indexed data structures like an array, so that you can make it very fast in the output. And that may actually make use of that code that allows you to write out assembly directly. So yeah. That's going to be the balance point for a language like this, I think, is you can be a total purist and say, we're only going to allow tail recursion as a looping construct. But when you think about actually writing efficient code, you will need normal loops sometimes for the fastest possible loop. Because if you need to do tail recursion, you have to deal with continuation context. And in theory, you wouldn't have to replace a continuation context because you're just calling the same function over again. However, it's probably not going to be as efficient as if you were doing a loop, especially if that loop is written in assembly and you're really tightly running the loop. So I think there'll have to be some balance between the flexibility of the language and the purity of the language, plus the sort of high performance aspects. Ramses says support for tree sitter. Well, I mean, that's sort of like separate from the whole thing, because you basically just write a tree sitter grammar for the language. And in theory, an existing Scheme tree sitter grammar would work for this because it's a lot of the same kind of syntax. Yeli says that's how Linus announced Linux as well. Yeah, I'm not gonna put this on the same tier as Linux by any means, but it's kind of an interesting thing, you know, just a fun little project to do. Defrag says, I have a general Emacs question. With Xwm, for some reason, I end up in a place where all workspaces have the same buffer. Is that a feature I am enabling by accident? Hopefully that makes sense. That is the case by default. In this workspace, I'm in this sclive april16th.org. If I go to workspace number 2, actually, I have persp mode on right now. But if I were to look at all buffers, I can go sc. Is that right? Come on, man. Let me get to scratch and then try this. All right, there we go. sclive. So this buffer is available on all workspaces. And that's one of the reasons why I do use perspective mode, so that I can restrict the buffer list to what is on a particular workspace. Exwm workspaces are just frames in Emacs, and the way that frames work in Emacs is they're all just windows into the same set of buffers. So that's basically just what you are living with to begin with. And yeah, so persp mode can be good for that. Perspective mode. Let's see. Let me pull that up really quickly in the browser so you see what I'm talking about. Persp mode. There's two implementations of this. The one that I'm using is perspective mode. That's right. Perspective mode. Emacs. I'm using this one by NEX3. Perspective EL, that's the right one. Okay, so basically this one allows you to have different workspaces, but it doesn't require you to have Llvm for this. This can work in just a single frame Emacs setup. So you have multiple workspaces that have their own separate buffer lists. I actually use this quite a lot for my workspace 1. I do all of my coding in, and I have separate workspaces with perspective mode in workspace 1 for different projects that I'm working on, and that allows me to separate my buffer list and my window configuration for things like I'm doing for work and things that I'm doing for writing for System Crafters episodes and maybe project coding, etc. So it's very useful for that. So I would definitely say check that out if you want to try something that will allow you to constrain things a little bit more. Nelson says, I'm here because Chris at Machine mentioned you make good videos. Well, thanks a lot for Chris mentioning that. I appreciate that. He also has a very cool channel. He and I are kind of riding together on the whole subscriber count. We're kind of neck and neck at the same set of subscribers, which is kind of cool. His channel is focused on Llvm, which is kind of cool. We're sort of like, you know, there's a Llvm channel and an Emacs channel. We're kind of growing together. That's a pretty cool thing. Peter says, was just fighting to get Idris 2 installed on the M1 Mac, got stuck on Shay's scheme, which is still not yet ported. It was forked by Racket and ported. In short, there are so many schemes. Yes, there are so many schemes, and the M1 processor definitely threw a wrench into the works. This is why I don't really care so much about supporting Mac OS, because Apple just does not care about developers, and they're just actively doing things to make people's lives difficult. Now, M1 sounds like a cool processor. Sounds like they've done really good things for performance on that, but every single thing that I've seen Apple do over the last 4 or 5 years, as far as like the updates to OS X and their hardware updates and everything, is just developer hostile. So I just don't care anymore. Ed says, I do like the sound of object code being in a structured S expression format, so you can start with a really low level form of the language and work up in Lisp. That's basically what I want to do. I want to make it so that it's just translations of code in the end. You have a low-level S expression syntax for the assembler, and then the higher-level language will be converted into an intermediate language that is in continuation form, and then that can be turned into the S expression form of the assembler, and then that can be compiled to machine code. So you have the possibility of having macros at every level, or just having it be a data format. So it's kind of interesting to think about it that way. Ramses says, what books are you reading for this project so far? Great question. So one thing that I've been reading, sorry, Viraj, I'm not going to subscribe to your channel. So the book that I'm reading right now, which is really interesting and a great background on the topic, is Linkers and Loaders. It's a book about basically that. It's like, how do linkers and loaders work? It's this book right here. So it gives a lot of background on different linker implementations. It's actually kind of an old book. I think it was published in 2000, but a lot of the topics still apply. And they tell you basically the job of a linker and the job of a loader. So there's sort of two halves of, or two sides of the same coin. The linker is what is producing the binary, taking all the object files, constructing the process image and putting it into a binary format that then the loader can understand. So the loader is part of the operating system, and like let's say in Linux, the Linux process loader, when you try to execute a process, it will look at that binary file for the process. It will extract all the information it needs. It will do some memory address mapping to dynamically linked libraries and maybe shared libraries, and then it will map virtual memory segments to stuff in that process, and then basically just get the process ready to run. So to understand how to write a linker, you kind of need to understand what a loader is going to be doing with that linked executable. So this book is kind of the canonical text on how to do that. I don't know if there's another one that describes it in the same way, but this is the one I've heard talked about by people who have been writing their own linker. So definitely check that out if you're interested in that topic. The only other thing I've been looking at kind of in depth recently is the ELF64 specification. So that is the binary format for Linux executables. If I can actually open this right now. I wonder if I have the right tool installed. We'll see. All right, so I'm going to pull up my downloads and see if I can get to this ELF64. All right. I don't know if this is the same one I'm looking at. Yeah, it's the same one I'm looking at. So basically, this will tell you the actual structure and format of the ELF64. So you're basically just running through this list of structs and whatnot to see how you write out everything. And I've written out a lot of this implementation already for just the program code segments. I haven't done anything for the sections yet. The sections are about what the sort of global memory is for your program or whatever strings you have that need to be loaded. And then the program segments are the actual machine code segments that get executed. So I'm just trying to get a basic process running right now. So I need to have the file header of the ELF file. I also need to have the program segment information. And when I have those things together, if I can get them set up correctly, I should be able to have a very simple application that can take machine code and run it. And aside from that, I've just been learning from various like Stack Overflow posts, blog posts, and just things I find online about how to use the various tools to analyze these ELF files and to understand from other programs how their stuff is structured. That's a good way to look at things. Like there's a hex editor that's built into Emacs. If you look at the hexl find file. So let's see if I can find a file for this. So let's go to Geeks Extra Profiles. I wonder Emacs bin/Emacs. So we're gonna load up Emacs in a hex editor. So this actually gives you a built-in hex edit view of the Emacs binary. And, oh, this is actually a bash script. I think that's what's happening here. So is it Emacs real? That's the right one. Oh, nope. Let me close this really quickly. Yeah, something about hexl mode causes my key bindings to break. So that's really annoying. But let me try one more time to load up the appropriate thing. So Geeks Extra Profiles, Emacs/Emacs/.Emacs real, bin/.Emacs real. Nice buffer issues here. Okay. There we are. Oh, come on, man. I think I've got something in the mini buffer here. There we go. Okay. So now we see, oh, this is still the, okay, anyway. The idea is that with this hex editor, you can actually see the bytes, the raw bytes of the program, and this ASCII view over here will give you some insight into what those bytes map to. So these kinds of tools are very useful when you're down at this machine code level and you want to understand what's happening in the program. This doesn't allow you to debug anything. It just allows you to see what's been encoded into the program. So if you know something about the format of an ELF binary, you can look at the hex and kind of understand a little bit about it. Let's see. Walter Reed asks, what distro are you using? I'm using GNU Geeks. Let's see. I missed some things up here, I think. Hookson asks, do you use Mxcalendar for anything, or the Emacs diary? I use Mxcalendar just to look at the calendar. Man, why is it doing this? I thought I turned off my display buffer A-list stuff. But I use it if I want to quickly check a date. But I don't use it really for the diary functionality. I use org mode for everything else. Garjola says, I mentioned that I had issues with Llvm and Selectrum. Yeah, for some reason, if I have a completion buffer or completion mini buffer open, like if I want to switch buffers, and I switch to another workspace, and then I switch back to the original workspace, for some reason, Selectrum cannot tolerate this. Neither can iComplete Vertical. And what happens is, anytime after I do that, the mini buffer will only be 1 line tall, and I can't see the completions anymore. And I have no idea what happened. I tried investigating it for a while, and I just gave up because I didn't have time to figure out why it's not working correctly. So I just went back to Ivy because Ivy can tolerate it. So yeah, there's some weirdness with switching workspaces in Exwm and then going back and then having everything be sort of screwed up. Andres says perspective is like an eclipse where you can select a set of windows to show, sort of like that. Yeah, it's mainly for window configurations and buffer lists. Pierce asks, not using Racket for creating a language? No, because Racket is more meant for language experimentation, and I'm trying to create an actual compiler. So, excuse me, I'm going to use an ideal scheme implementation for my goals, which is Chibi scheme in this case, and then go from there. Pavel says, have you tried managing Node.js stuff in Geeks? I need different versions of Node for different projects, so I use Anaconda, but I wonder if one can use Geeks for that easily. What I've been told, what Yele told me, was that they've got Geeks, sorry, they got Node 14 in Geeks now, but I don't know if there are separate packages for that at the moment. Or I guess you can do the version specifier, but Node, yeah, Node's only 10 right now because I haven't pulled recently, but you could do different Node versions for sure. For dependencies, though, not so easy because there aren't many Node dependencies inside of Geeks, so it would just be the Node versions. Excuse me. Let's see, what else did I miss here? God, another thing is broken. Okay. Ramsey says, what is the first step for this project? I mean, how does the first line of code looks like? What is the first brick of this project? Well, I mean, the basic thing would just be making display work. Hello world. So the idea here being that I would be able to compile a program that would be able to put this string inside of the string section of the binary. And display would be a function that would have a simple implementation that would be able to invoke the printing routines in Linux system calls. Since I'm not going to have the standard C library to call printf, I would have to go lower level than that and do my own implementation. So something like this would be a good starting point, or even simpler than that would just be returning a value or just doing a simple addition like 1 + 2 or something. So for the language level, that would be where I would start. It's just like really simple, get very simple syntax and expressions working, and then build up from there. Then you have to get into things like defining functions, and then calling functions, and then decide when I want to actually try to get the continuation aspect working, which is going to take a lot of work, I think. So yeah, the very beginning is just going to be, very simple expressions, and there's not going to be very much productive happening in the language at the beginning, but it will be fun to implement, I think. Let's see. Bayant asks, where the other Lisp variants stand in comparison with your ideal Lisp? Have you given a thought to extending any other open source Lisp? Yeah, I've been working with a few different implementations of Scheme, Chibi, and Guile and Gambit. But they're all based on the idea of having garbage collected, basically virtual machine style code. And, I think that Guile can do JIT compilation. Gambit compiles to C, which then compiles to native code. But still, those don't do exactly what I'm trying to do, which is I want to compile directly to native code. I want to JIT directly to native code without any kind of layer in between necessarily. So that's why I'm trying to do it that way. Hi Red says, why are you doing this? Sorry, I just joined the stream. You'll have to scroll back about 15 minutes and then I'll tell you why. Ed Bowler says, if you use continuations at the bottom, the error message story changes, right? You can't use a stack trace as the de facto state of your program. How can you replace that developer debugging crutch? Great question. The way that it's done in Gambit is whenever there is an error, it will drop you into the debugger, and then you're able to actually list the continuations at that point and step backward in the continuations. So it is sort of like a stack trace. So if you wanted to have a stack trace, you would have to keep track of which continuations you've gone through so far, which is kind of like a stack in that case. Which, since continuations are not like a stack where there's like a clear path, it might be interesting to figure out how to show that correctly as a stack trace. But I imagine other continuation-based compilers have dealt with that somehow, like the ML compilers and whatnot. So there must be a reason, or sorry, there must be a way to do it somewhat effectively. But it does bring up a good point. A lot of times in Lisp implementations, when you hit an error, it does dump you directly into Debugger, which is very useful for investigating problems. So the question becomes, does this language have a built-in debugger? I would say it would be cool, because if you don't need to have an external debugger, then you can do a lot of things directly in the program. But it would have to be something that's only in debug mode. It couldn't be in a release mode of the binary, because you wouldn't want to have all that debugging stuff built in to your actual binary you want to give to someone. So definitely something you could do in a debug mode version. There is also the possibility that you could have an external debugger that you can attach to the process potentially, but you would not have a lot of the debugging symbol information unless I produced a separate symbols file that allowed you to get that info, which is also a possibility. But yeah, debugging I haven't thought about very much, and obviously errors and stack traces I haven't thought about very much yet either. So it's great that you asked, because I need to think about that. Tape House says, guys, help, can I reduce Lux encrypted disks safely? I don't know the answer to that question. Need to reduce 200, 300 gigabytes for other OS. I don't know if there's a way to disable the encryption and then resize and then re-enable it. That's something you can do in Windows, but I don't know about in Lux. You might have to search, what's it called? It's not Stack Overflow, it's like the server version of Stack Overflow. But yeah, unfortunately I can't help you with that question. Let's see. We're doing pretty good on time, I think. So yeah, I think this is gonna be a pretty fun project. It's definitely got me excited about coding again. You know, it's kind of weird to do coding as a job and also do it in your free time because, you know, it's a lot of coding. But it is kind of refreshing, I think. Yeah, server fault is what I'm thinking of. Thank you, Pavel. It's refreshing to the mind, I think, to think about a different problem space a little bit and to learn something new, because it kind of gets you reinvigorated. It kind of gets you more energized to solve the problems you have to do both at work and in your personal time. So I think it's a good thing to do, even if it can be risky for various reasons. Thanks, Ashraz, for the suggestion. Martin says, do you have a time span for when you think you'll have a substantial chunk of this project done? No, I can't imagine when I'll be at a point where I'll have a substantial chunk. However, the way I like to do things with projects is to have a specific program that I'm trying to implement so that it drives my learning and also drives the path I take to get to writing that program. So I use that approach for learning like a new framework or language. I would also use it for this project as well. So what I want to do is to write a very basic game using this language, because that's one of the whole points of this, is to be able to do game development. And if I can get started on that path to do like a very, very simple game, like let's say, you know, Pong or Tic-Tac-Toe, like very, very basic, then it would enable me to implement only what's necessary to get to that point. So to be able to do a game, I would have to be able to compile basic code, obviously. I would also have to be able to link to either static or dynamic libraries and call functions in them. So if I wanted to either call, like, let's say OpenGL or call SDL or anything like that, I would have to be able to call external libraries. So that already sets a course for me for the whole tool chain. So the linker needs to be able to do linking to dynamic libraries. The assembler needs to be able to generate code that can be used by the linker. The compiler needs to be able to generate assembly code, basically. So I know what I need to do to get there, basically. So that gives me the path to learn what I need to do to get there. Now, to how long it was going to take me, I have very limited time to begin with because I'm making videos, I'm doing these streams, and I'm also working and raising a kid at the same time. So it's kind of a very difficult thing to estimate because I don't have a whole lot of free time. But I would hope that within a year, I would be able to accomplish at least that goal. And then after that, we'll see where I can get. Ramses says, what about contributions? At this moment, I'm not really thinking about contributions because this is mainly a learning project, but later, whenever things are more clear and the basics are figured out, I would definitely welcome contributions, I think. Garzola says, not to spoil the party, but 1 + 2 and Pong already work on my machine. That's great. It works here too. I can just run it in Emacs if I want to. What else did I miss here? Garzola says, why not show a bit of the code I already have? Because I don't have it on this machine, and it's also very, very basic. So what I've done so far is I've written very basic scheme code that will write out the binary representation of an ELF file header, and we'll take a chunk of assembly code and then try to write it out into a binary, but it doesn't work yet. The ELF header writing does work because I can use the ELF tools to read information. If you use the read ELF command, I can get information out of it. It says it's a 64-bit binary and some other information about it, but right now I have to learn how to do the memory addressing correctly before I can produce the final binary that has that machine code ready to run. So I'm still getting there, and I have very limited time to do it. So it's very, very early right now. Let's see. Ed says, what do you think about functional programming and immutability within the standard library? I love immutability as a programming paradigm, like, using pure functions and immutability. However, I don't know. I would like to use it in some places, but I don't think it should be the very core thing to be used, because for performance, you kind of need to deal with mutable data in a lot of cases. With immutable data structures, there's a lot of bookkeeping, and I mean, you do them with shared memory, basically. Like you have a structure, like a tree structure, let's say. You don't rewrite the whole tree if you change one element. You only rewrite the subsection of the tree that's changed. And then you have a pointer to memory. So it is something you could definitely do in this language I'm talking about, but I wouldn't use it for high performance code. The game engine that I wrote in Scheme, I was actually using lists in Scheme for a lot of the data structures in the language, which was interesting because it let me do things in a very Scheme idiomatic way, but it's kind of slow and it's not very memory efficient because, when you're consting things together, you're allocating new const cells, and you're using pointers to various different memory locations. So it's kind of like the opposite direction you want to go if you want efficient memory access for a data structure. So I would definitely like to have immutable data structures in the cases where they are useful. Like, let's say making user interface code. I would like to have it there because the patterns you can get from immutable data structures for UI is pretty great. But for writing an audio synthesizer or writing a game engine, I think that a lot of cases you're not going to want to use immutable data structures for that. That's just my opinion, but I think I'm probably right about that. So Rudy asks, why are you unhappy with the Cprintf and the standard library? I'm not unhappy with it per se. It's just I don't want to use it. I want to be able to produce an entire binary myself without the need for an external library like the C standard library. If it turns out I need something like that, I'll use it, but I don't think I need it because the Linux system call, the set of system calls in Linux allows you to do a lot of things. You can read files, you can write files, you can write to standard in, standard out. I don't need printf to do that. I can write my own code in assembly right now that does not require the C standard library, and I can print something to the screen. So I would prefer to do everything from scratch until I see a real need to pull in a dependency. Ramses says, what is an ELF file? ELF is the Linux binary file format, basically. It's the format for object files, executable files, or library files. Let's see. Garjola says, I've been joking. Yeah, I know. Don't worry. But I'm always impressed by your skills and projects. The .crappers mode is the best eLisp tutorial I've seen, self-contained end-to-end. That's what I intended. I wanted to be like here's start to finish. We're learning Emacs Lisp and we're making an actual package. And I'm pretty happy with how it's been turning out so far. It needs to be cleaned up a bit, but other than that, I think it's worked pretty well. I will admit I haven't actually been using it day to day. I need to do that to try it out, but it should be working. Let's see. Hookson says, have you tried using the RMS bolt package for viewing what the generating assembly is for the code as you write it. Is that the one I'm thinking about? Let's see, RMS Bolt. I've heard of another one like that. And Compiler Explorer for Emacs. Showing you the assembly output of a given source code file. Yeah, you know, this kind of thing is exactly what you should be doing whenever you're trying to learn how to write a compiler. Basically, go like write C code for something that you're trying to do in your own language. Compile it to assembly with GCC, or use a tool like this to look at the output assembly and learn what they're using, what kind of instructions they're using, how they're putting things in registers, etc. Instead of reading a book, you can learn a lot like this, basically. If you want to know how to call a function, just write a C file that calls a function or calls a function from a standard library, and then look at the assembly code that comes out of it, and then you'll see the patterns that are used. That's sort of the magic of this whole thing, is that we're so far removed from how things actually work at the low level of the system that, you know, you write code in, let's say, Python or something, and you're like, okay, cool, this is Python, it's great. I know how to write something to the screen, but I would have no idea how to do that myself, like at the you know, machine level of the system. Well, it's not really that mystical. It's just a different way of doing things than what you're used to, and you can very easily find out how it will be done just by compiling some basic C code and then looking at the output. So it's a good learning exercise to do this, and it's cool to see that there's actually a package that makes it a lot easier. Apparently it does it for multiple languages too, so if you have OCaml, it can put out the assembly for that. Rust even, which is like, I think probably Llvm, intermediate language. Haskell, Python, that's cool. So basically any language that has an intermediate representation is able to put that out. Common Lisp, that's very interesting actually. So yeah, I might actually try this out. Thanks a lot for bringing that up. I didn't know about that. Garjola said, Godbolt's Compiler Explorer was useful to me when I was heavily using templates and lambdas in C++. Yeah, definitely, that could be useful. I could see why. Bayant says, what about using LLVM backend in the initial stage to which we can JIT the code and later replace the backend with your personalized one? It's basically what other language implementations have done, and they eventually change anyway. I would rather just learn everything from top to bottom because it's fun. That's sort of the whole point here. I'm basically trying to teach myself how to make a compiler while doing it. Let's see. Excuse me. What else? So we got about maybe 10, 12 minutes left in the stream. Anybody else got any other interesting questions or thoughts? Thankfully, I finally am getting close to being done with my stupid taxes. And taxes is like the most annoying thing to have to deal with every year. And now that I'm getting to be done with that, I can finally go back to using my weekend time to hack on projects. So I know it sounds ridiculous. Like, what, it takes your whole weekend to do taxes? No, I only have like maybe 2 hours per day on weekend days to do anything other than, you know, responsibilities I have. So that's whenever you become a full adult with kids and life responsibilities, you know, your hacking time has to be very focused. You got to be like, all right, you know, I have a very specific goal I'm trying to accomplish and get it done in the limited time I have available. But honestly, I found it to be a very focusing thing where before you're like, oh, I have plenty of time, and then you never do anything. It's just like procrastination city. But now whenever you actually have very little time, you're like, well, I really want to do this. I'm gonna have to do it fast. So it sort of inspires a new level of efficiency, I guess you could say. Ramses says, async code, streams, and other fancy stuff. Yeah, I would love to figure out how I would do some of those things. Now, one of the benefits of using continuations is that stuff like async becomes very easy because it's sort of built into the model. Whenever you want to, so the way that async typically works in a normal language that's stack-based is that the compiler will convert code that has an async call to some function that completes asynchronously. It will convert it into something like a continuation where the rest of the code of the function gets turned into a function, And then when the async code completes, it calls into that function. It's basically a continuation converter of some sort by itself. But if your language already has continuations as the compile target, then you don't have to do anything because it will just work. You just return whenever you're ready to, and it's done. I believe that's the way that it goes whenever you want to do async. Now, doing things like streams or channel-based programming, I think that also will be fairly easy to do with continuations. The reason why is because another interesting aspect of a continuation, at least like in Scheme, when you use call cc, you're creating a continuation from the current context of a function and passing it to someone else. Now, whenever that continuation gets called with a result, it's going to jump back to your code at that point in time and then run the rest of your function again. So if you want a stream or you want like a subscription pattern, you just create a continuation in your function, pass it on to someone else. They can keep calling that continuation multiple times and it will jump back into the body of your function and then continue running whatever the code was there before. So you just basically get that for free, just having continuations in your language as a first-class citizen. You can implement event streams, you can implement channels, you can implement all sorts of things like that. So it's very cool functionality that I would love to have as a first-class citizen here so that it can be used to do arbitrary control flow constructs. Tiago knows what I'm talking about. As a father of 2 small kids, I can totally relate to that. Yeah, it's very difficult to find time to do things. Garjola says, about learning and improving one's skills, go check out Prot's last video. It's about moral lessons learned from learning Emacs. That's pretty cool. I haven't checked that one out yet. Pavel says, Emacs Zone is my favorite to enable after doing org mode presentations. I'm not going to run it, but I'm going to look it up and see what it does. Zone out completely. Yeah, if I run that now, it might break the stream. So I think that's not a good idea. Ramza says, where can I read about continuations? Probably the Wikipedia entry would be a good start. Let's see. Oh, okay. That's a weird book. All right, so Wikipedia continuation. A continuation is an abstract representation of the control state of a computer program. So yeah, it's a little bit abstract and theoretical, but I think there are some examples here of how to use it. I will warn you that looking at Scheme code that uses call cc is going to make your brain hurt at first because it sort of looks like quantum physics, but it's really cool. And once you learn how to use it, you can do a lot of things. Like right here, they're implementing coroutines using continuations very simply. So in this case, there's like a yield basically that you can call to yield the execution flow to another function. What else are they saying here? Continuations simplify and clarify the implementations of several common design patterns, including coroutines, green threads, and exception handling by providing the basic low-level primitive which unifies these seemingly unconnected patterns. They provide elegant solutions to some difficult high-level problems like programming a web server that supports multiple pages, accessed by the use of forward and back buttons and following links. So if you've ever used a language or programming environment that is event-driven or has an event loop, like let's say JavaScript, you kind of know about this a little bit already because so long as you are calling functions that are asynchronous in JavaScript, the runtime has the ability to sort of schedule things to happen in a more non-linear way, and it makes the code. It gives more opportunities for things to happen in the code that don't happen whenever you have just purely imperative code all the way through, like in like C or something. In JavaScript, there's a lot of functions that require callbacks, and that's basically like an explicit continuation. So you call a function, and then once that function completes, it's going to call the callback that you gave it. Node.js uses this a lot for all of the things that touch the file system because it's using event-based I/O under the covers so that it's non-blocking. So basically, instead of blocking on a call to reading from the file system, it returns immediately, basically, and then it will call a callback in the end whenever that chunk of data finally gets read from the file system. So a continuation is a similar thing where when you have continuations, your code can be non-blocking and it can be easily multi-threaded, not literal OS threads, but sort of it can be treated as threads because you have the ability to schedule things to be executed at certain times. Andre says, yeah, you have lots of times to do things like raise children. Yeah, that's true. Let's see. Andrea says, maybe you talked about this already. I'm using Emacs and Exwm all the time. Any ideas what to do against the freezing of Emacs? It only takes a minute, but it's annoying. Well, as you saw in last Friday's stream, I did have Emacs totally freeze up on me because I did something in Guile Scheme that caused Emacs to hang. So it's kind of rare for me that it totally hangs like that, but just hit Control-G a bunch of times if it seems to hang, and maybe it will release. Other times, maybe a program gets stuck and then it locks everything up, so I have to switch to a different TTY and kill that program. That happened to me earlier today, actually. I tried to open the inspector in Firefox to mess with an element on a web page, and for whatever reason, Firefox decided to start using 100% CPU, and it locked everything up, so I had to switch to another TTY and then kill Firefox, and then I was able to switch back and start using things again. However, you can't really blame that on Emacs and Exwm because it's more like Firefox just took over my machine. But for things where something gets hung by Emacs and you can't click on things after that because Emacs event loop is hung, either Control-G. Sometimes you can try to send the user 1 or user 2 signal to the process to unblock it, but if Control-G doesn't work, sometimes the other signal doesn't work either. But yeah, it's not very often that Exwm locks up to the point where I can't use it, but when it does, you have to kill stuff sometimes. Yeah, Garjola says pkill sig user 2 Emacs can be useful. I haven't tried that enough to see whether it can get you out of trouble more reliably than Control-G, but it might. So Hookson says, are you able to use Exwm at work as well? In my case, I can't, so I tried EAF and found the browser to be very laggy. I do use Exwm at work, and that's mainly because all of the work that I do on a day-to-day basis can be done in Linux and without any kind of complicated tools or UI or anything. I'm mostly using command line tools and compilers for the work that I do, so I can very easily use Exwm and Emacs for everything. For my job. Everything else is just in a browser or in a desktop app that sometimes I have to use on a different machine because I need Windows, but it's not very common. Hookson says, I've used sig user 2 on Emacs and sometimes it leaves it in a bad state. That's good to know. I didn't know about that. Pavel says, I've tried launching Exwm with a bash script, which restarts Emacs automatically unless it's exited correctly. It works pretty well. I just didn't like Exwm too much. Yeah, that's a good thing to do if it's hung. You could do that. But for me, I just go kill Emacs from the terminal, and then it restarts my Xorg session. So it works fine for me to do it that way, if I have to. Ian says, always wondered how many Emacs users there are at Microsoft. There's probably a few. I don't know. I'm not sure about the answer to that question, but I know of probably 3 or 4. One of them is here right now, or was here. So let's see. Got about 3 or 4 minutes left in the stream right now. Garjola says, after you do the sig user 2 signal, you may need to use Emacs top level. Interesting. Is that to bring it back to, yeah, exit all at recursive editing levels? I didn't know that that function exists. That's cool. Andre says, I like my theme code. It changes with time. Are you using a package to change your theme at a certain time of day? Antonio says, when Emacs freezes, I usually make it react redimensioning the window manager window. How do you do that? Yeah, that's kind of an interesting idea, changing the theme that you use based on time of day to help with your eyes, basically. I use the Redshift program to do that. It just changes the color temperature of the screen at certain times of the day. And it works well enough for me. But I still have issues with going to a website with a white background and it completely blinds me. So I usually have my machine's brightness down to probably about 5% or less. Garzola says, if Emacs really hangs, I use parted. You mean you delete your partition? That seems pretty extreme for getting rid of a hung Emacs process. All right, so I think that was a very fun conversation today. Hopefully you found it interesting, and since people seem to be somewhat interested in it, I will definitely give some updates along the way as I go on the Lisp compiler project, the Mesh project. Definitely check the... let me see if I can drop it in the chat right now. Check out the links I posted before for the mailing list and the repo. I'll put it in the chat right now. If you want to join those, like I said, the compiler repo is empty right now because I haven't committed anything yet. But keep that bookmarked to check out in the future, and then I'll let you know whenever anything interesting happens there. And for those of you who are watching the recording, check out the description. I'll put the links there too. So next week, I think that what I'm going to do is the next video in the Emacs Essentials series, where I'm going to talk about how to do efficient selections and talk about how Emacs manages marks and regions. That might be pretty interesting if you're doing a lot of text editing. And then the week after that, we're going to be back to the Geeks series, I think. We'll talk about using Geeks as a package manager. We talked about how to install it as a package manager, but now we're going to talk about the different ways to use it as a package manager that apply not only to using it on a foreign distribution like Ubuntu, but also the actual Geeks system itself. So the reason why I broke up the video like that is so that we could talk about the general concepts of using Geeks as a package manager, no matter how you're using it. And then next Friday, I don't really know what we'll talk about yet. Maybe we'll do another .file detective. So if you have any suggestions on cool configurations you've seen from other people, let me know. I'm interested in doing some more of that because people seem to like it and it's kind of fun. And we learn a lot from seeing what other people do in their configurations. So let's try to do that again, I think. All right, before I head out, I would definitely like to thank my sponsors. These people have decided to support the work that I'm doing, making videos about Emacs and GNU Geeks, and I'm very thankful to them for deciding to support the channel in this way. If you are interested in supporting the work that I'm doing, definitely check out the links that I have in the description below. I'm on both GitHub sponsors and Patreon. I also have the link to PayPal for one-time tips. And if nothing else, definitely just like the video and share it with your friends. Share my channel with your friends if they're interested in learning more about the topics that we talk about here, because the more people we have here with us, the more people we have to talk to about all this insane stuff that we like to do. So with that said, thank you all for being here today. I really appreciate all the engagement and all the very nice and useful comments, like really good comments on the language design aspects. Really appreciate that. And until next time, hope you have a great weekend and happy hacking. See ya.